The universe is a limitless fractal made basically out of a limitless number of vast blasts known as minimal huge bangs. In the event that you consult a science course book published before 2006, you will see that Pluto was incorporated as one of the 9 planets in our solar system. However, this is no longer the case. Nearly a decade ago, the International Astronomical Union, IAU, reimagined Pluto's status and excluded it as a planet. Now the IAU is again discussing this issue since NASA has provided clear pictures of Pluto, which is now viewed as a dwarf planet. Join us on a journey to the far reaches of our local planetary group to explore the first images of Pluto in our history. Assuming you're keen on keeping fully informed regarding news from the universe and its surroundings, subscribe to our channel. Be sure to like this video, share it to reach more people, and turn on the notification bell. We've made some amazing progress since the historic Apollo 11 mission, but the immensity of space presents a myriad of unanswered questions. This is where NASA's groundbreaking James Webb Space Telescope project aims to uncover a universe of its own. This fantastic project builds on NASA's past missions, and there is great interest in interpreting new discoveries from ancient times. We are naturally curious to learn more about the Big Bang and how our solar system came to host life on one of its planets. The James Webb Telescope, however, has its sights set on the future of our local planetary group, revolutionizing our understanding. Despite the fact that it is significant to find out if we need to think back for authoritative answers about our universe, we may need to re-examine them. The Pluto question has been the subject of discussion in the field of space exploration. Because of the James Webb Telescope and the discoveries it has provided, we have more data to investigate our local planetary group. It seems that the $10.1 billion investment in NASA has led to an update of science textbooks to include all that we know about Pluto. This time, it is likely to regain planet status. Here's why. Our knowledge about Pluto doesn't end with the controversial IAU decision in 2006. In fact, it is the new and restored capabilities of the James Webb that have provided the pictorial evidence required to strengthen our theoretical understanding of this putative planet. Although past observations determined which objects are considered planets and which are not, the IAU had minimal solid data on which to depend. The rules used for this classification may have been questioned following the decision in 2006. 2 different scientific scenarios on the issue have arisen. Some believed that the IAU was hasty in declaring Pluto a dwarf planet, while others quickly embraced the new non-planet status. Most spacefarers have remained uncertain regarding this situation. However, due to the captivating discoveries of the James Webb, the question of Pluto's status remains. The first sharp images of Pluto provided by NASA are rewriting how we understand astronomical history. The first and primary human experience with Pluto was conducted by the New Horizons mission, which has been ongoing for nearly a decade. In July 2015, the mission accomplished its objective by passing near Pluto and its many moons. This was the first time humans had the opportunity to get a close look at the space artifact and gather the most comprehensive data set to date about its moons and surface. The New Horizons mission opened up exceptional opportunities for NASA in its exploration of the Kuiper Belt, a deep region of space. The principal accomplishment of the mission was the detailed investigation of Pluto, now viewed as a dwarf planet, and its largest satellite, Charon. It also managed to capture clear images of the 4 other satellites known as Nix, Hydra, Kerberos, and Styx. Over a period of 15 months, the mission gathered data, including the encounter with Pluto and Charon, amounting to 6.25 gigabytes. What does this data mean for NASA regarding the dwarf planet? First, the discoveries were so pivotal that researchers needed to develop new data models to better comprehend Pluto's surface and climatic conditions. It was found that the dwarf planet was undergoing significant changes in its surface and climate. It was clear that Pluto was far from being a dormant body. It was evolving at a rate that astounded NASA and challenged what was previously believed about this putative planet. The New Horizons mission was substantial, and its encounter with Pluto occurred almost 9 years ago. Since then, the field of space exploration has seen dramatic improvements through technological intervention. With the addition of the James Webb Space Telescope, the possible outcomes are becoming endless. One could even say that we are getting increasingly closer to a total understanding of our local planetary group. However, there is an issue with missions like New Horizons and any decisions to explore planets farther from the Sun. The problem lies in the prioritization of resources, as investing millions to research a scientifically significant planet might raise questions about the existence of potential living things elsewhere. Why head to the edges of the local planetary group? These are challenging inquiries, to be sure. However, the New Horizons mission marked a turning point in the history of space exploration. Not only did it open new avenues for NASA to invest in the study of Pluto, but it also sparked our curiosity in further investigation beyond the known limits. In the case of Pluto, its study is crucial to building a broader scientific understanding of other small planets. Despite the fact that it lies in a cold, dark region of the universe, the first images of its surface proved pivotal enough to reveal that Pluto is an active object in our planetary group. As the saying goes, a picture is worth 1,000 words, and these crystal-clear images from NASA provide us with significant information. First, Pluto was found to show some care. Most land peculiarities on this diminutive planet are derived from its core, scientifically known as Sputnik Planum. Shockingly, incidentally, Pluto literally depends on its heart. A quick look at NASA's high-resolution images revealed that this heart is a white ice sheet and almost frozen left ventricle of Sputnik's heart. It resembles a massive nitrogen ice sheet crossing thousands of square kilometers. Another outstanding topographical feature of Pluto's surface is that the axis of its rotation has undergone significant reorientation, a process that researchers call precession. This was unknown to NASA prior to the mission. The dwarf planet's bowl is in the opposite position than anticipated. This reorientation has significant ramifications for understanding the dynamics and evolution of Pluto as a planet. In simple terms, the flowing axis between the moon Charon and Pluto is being affected by Sputnik Planum, the core of the dwarf planet. This effect has reoriented Pluto so that its bowl is more closely aligned with a flowing hub, something that was not previously known. We have always known that this ancient planet is remarkable for obvious reasons. However, what was not known is that Pluto's cold surface also causes a tilt due to the unevenness in its mass. The core of the dwarf planet is a 4 kilometers thick layer of ice, which likely contributes to that titanic mass. When combined with tides, this cycle can cause the reorientation of the planet's axis in search of balance on its own orbit. However, the ice sheet alone is not sufficient to produce a drastic reorientation point or to create significant levels. As we mentioned before, technologically supported investigations can reshape our cosmic history, and this is just such a moment. Researchers have also found that Pluto is a world with an ocean of its own. Beneath its thick ice sheets and ice-covered surface, Pluto's interior contains a vast sea that also impacts the reorientation of its rotation axis. This discovery is remarkable for multiple reasons, but most importantly because it completely changes how we understand the planet. The likely presence of a sea beneath Pluto's frigid surface ignites new questions and possibilities in planetary science. It challenges our understanding of what constitutes a habitable environment beyond Earth and prompts us to re-examine the dynamics of celestial bodies in the far reaches of our local planetary group. This sea, estimated to exist based on gravitational data and now strongly supported by the New Horizons mission's discoveries, represents a potential reservoir of liquid water beneath a frozen exterior. Understanding Pluto's geological cycles is crucial to appreciating its evolution over billions of years. The dwarf planet's surface features, including its prominent heart-shaped region and the unexpected reorientation of its rotation axis, provide enticing insights. Sputnik Planum, the heart's left ventricle, serves as a unique geological feature. It is believed to be a vast basin that may have formed due to a subsurface sea freezing and causing the surface to collapse, or perhaps due to an impact that exposed material, leaving a deep depression. The New Horizons spacecraft's encounter with Pluto in 2015 revealed a unique world, far from the cool, inert body it was once thought to be. The mission captured detailed images of Pluto's diverse terrain, including mountains made of water ice, vast fields of nitrogen ice, and regions with intricate patterns resembling cellular networks. These features suggest dynamic geological processes potentially driven by internal heat sources or interactions between surface materials and Pluto's thin atmosphere. Pluto's atmosphere, although thin compared to Earth's, plays a significant role in its surface dynamics. It comprises predominantly nitrogen, with traces of methane and carbon monoxide. During Pluto's elliptical orbit around the Sun, these volatile gases sublimate from its surface, creating temporary atmospheres that shift with seasonal changes. Understanding these atmospheric processes helps researchers recreate Pluto's climatic history and its ongoing evolution. The New Horizons mission's discoveries extended beyond Pluto itself to its system of moons. Charon, Pluto's largest moon, revealed a surprisingly different landscape, including a vast canyon deeper than the Grand Canyon and a dark region nicknamed Mordor for its distinctive hue. Other moons, such as Hydra and Nix, showed irregular shapes and cratered surfaces, indicating a history marked by impacts and geological activity. NASA's investigation of Pluto, fueled by the data gathered during the New Horizons mission, continues to push the boundaries of our knowledge. The implications of these findings resonate not only within planetary science but also with our understanding of the broader cosmos. The ongoing analysis of data collected during the mission will further inform our understanding of planetary formation, evolution, and the potential for life beyond our own planet. In conclusion, the exploration of Pluto through missions like New Horizons and advancements like the James Webb Space Telescope reshapes our perception of our solar system. Pluto, once relegated to the status of a dwarf planet, emerges as a vibrant and evolving world, raising profound questions about the nature of planetary classification and the potential for habitable conditions beyond Earth. As we delve deeper into the mysteries of Pluto, we stand at the precipice of exciting discoveries that may forever change our understanding of the universe.